Welcome to Radio Fixer's channel. Subscribe for upcoming videos.
Hello, welcome back to part 4 of restoring Kent 402 metal tube radio. If you're a new subscriber, I highly suggest to go back and watch all part of restoration. In this part, on part 4, we're going to discuss, why we need to replace non-polarized with polarized AC power cord and how to do that. Next, we're going to test the dropping voltage. We have to drop the voltage, as you know, because we have 11 volts extra coming through the radio. Of course, we're going to use first resistors. The resistor came with the radio and other resistors to upgrade it. And then we're going to use just the diode to test it, to see if by just using diode is that going to reduce the voltage. And then at the last, we're going to combine the resistor and diode to test. I hope you enjoyed this video. You take care.
Okay, folks, let's talk about a few things. This is for the brand new person who want to start the hobby. If you have electronic background, you just fast forward this section. Majority, almost all the old radio here in United States, when you purchase them, it comes with a plug like this. They're both same size, so when you plug it in, you don't know which side is a positive, which side is a negative. Especially with the old radio, you want to know which one is positive, which one is negative, because you can plug this old radio, this way or other way, and depends how you plug this into the electrical source. The radio will work, but the issue is that it might be dangerous to actually touch the radio by mistake, touch the metal part. Even the knobs, they are not metals, but that's the reason they made them that way. But again, for safety, you want to get rid of this type of plug. You want to get rid of them, and you want to use a new plugs that here in US, you see there is a different size, and every plug in the households, there is a small size and a large size, and checked on internet, the small one is always positive, and the bigger side is a negative. So what you want to do, you want to make sure, the positive side, the small side, be hooked up to the switch. So I'm going to show you, how to do this. Of course, it's pretty simple. So be careful when you do this test before you plug this in to the power source. You want to hook your multimeter. See, there's a 2-wire here to each section, like this. Make sure they don't touch each other like that, okay? And then I'm going to put this on, I want to read AC, not DC. You want to read AC volts. So you hook up, make sure these are apart. You hook up, this is because these are designed a different way, then that they're different size. So there's one way you can plug this in. When you plug it in, it's 321, sometimes it's 122 volt. It comes, out of the plug. Again, do not touch, you can't get electrocuted. So we know now this. So that is the power, it comes out of the wall, right? So we're going to unplug this, all right? Again, we don't want to get electrocuted. No, we need to mark the wire, which one actually connected to the positive side. See, this is the small side, again, is a positive. So the best way is, put your multimeter, doesn't matter which side, put it here, the small side, right? And here we're going to test to see which wire is actually connected, to that positive. So we're going to put the multimeter where actually is making sound right here. That's why you need to have a good multimeter to do this type of thing. And then I'm going to take this side. Let's see which one is positive. If there is a sound, it means there's a connection from this side to the small side, of course. You see, there's no sound. So that is a negative side. This is a positive side, right? So this is the positive, right? This is where I need to go to the switch, the positive side. So I'm going to mark this, use something to mark it. I know this is positive side now. I know this need to go to the switch. So again, no sound. It says with a small one. And as soon as I put it here, sound. So we marked it correctly. Again, please make sure to put positive to the switch, because when you turn off the switch, then it's going to turn off that. Still the negative side goes through the radio, but at least it doesn't make any connection to this. I hope that makes sense. This is for safety. That is what I do with all my radios. I replace this one, that they're both same size, replace it again with something that is marking US. I'm sure overseas you should have the same thing as well. If if yours is different than ours system, they're both same side, after you find which one positive in your country, you mark it red. Okay, you mark it red, so that should go to the positive side. Also, again, if yours is different, find out which one is positive and mark that as well. Mark it so the red goes to the other, that you marked. Again, we do this for safety. You're dealing with the old equipment. Those years, you could plug this anyway, this side or other side, but if you put it the wrong side, it could become a safety issue. And we want to make sure that you all enjoying this hobby and you're safe and secure. And we discussed about the other equipment that you need to be safe. You definitely need something called variac, and also isolation transformer is the must. You got to have those, at least isolation transformer. That is very important to have. Hopefully this helped for those of you who are brand new, and let's be safe and enjoy this hobby. I suggest very highly to buy one of these in Amazon. It's called Kilowatt. It's a P3 that it read everything for you. I hooked this up to my variac, so I can adjust how much electricity comes inside. And then this one is a direct. If I switch this to other direction, I'm going to activate the temp bulb tester, but I don't need that. If I go in the center, everything shut down. All the way in the bottom, I'm going to activate the electricity. This is going to be direct, and the only thing you need to do, press this button here, right here, and you see it tells you watts, amp, and also the volts. And you see right now is red.
by pressing this, I'm going to activate it. It's a very good unit, you know, it really helps you out to read what's going on inside, what's actually happening, you know, with your radio.
All right, you might ask why I'm working on chassis again. I have to thank Steve, the troublemaker, you know. He sent me a message. He said, have you watched Don at Restored Old Radios? You know, he restored one of these. His is, you know, is Irvin 402. Mine is Kent, but they're same chassis. So I checked theirs. Oh no. If you haven't watched, you know, the Don video, you know, he's unbelievable. He's one of my mentors to learn how to do all this. And so he was talking about the sand resistor, which we discussed earlier. So I contacted Don, sent him, you know, a message. I said, Don, you know, I saw years ago that people, they add diode to their, you know, radio to reduce the amount of electricity goes inside, and also especially for these small radios, you know, to reduce it because they get so hot. And he was nice enough to send me this article, you know, and the Don is awesome, you know. Anytime I ask him for anything, he's there. And so he sent me an article. I'm going to put this article up here for you, you know, if you have a chance to read it. Of course, all the calculation was over my head. That's what I told Don. I said, Don, I have no electronic background, you know, but I looked at the summary. I, of course, look everything, calculation, of course, was, you know, difficult to understand, but his summary was awesome, you know, and yes, you know, that you can use, you know, this type of diode. It's that I bought is 1N5408, is a 1000 volt 3 amp diode. You can actually install this inside the radio, so reduce the amount of electricity goes in radio. And because this thing is so darn small, you know, and they have to find a way to do it. Also, you know, I think somewhere in his article I was reading, you know, you want to keep this diode away from, you know, your resistor, like the sand resistor that I have, you know, it came with this radio. As you saw, the resistor still is a 71 ohm. It still is in good condition. So you know how I am. I like to keep everything original. So I'm going to put that back in. Even I replaced it with this type of 5 watts, 100 ohm. See this one? And the radio worked very well, but it gets so hot. No wonder all the wax, they were leaky. Even this, I think this is a speaker transformer, if I'm not wrong. This is all, you know, wax was coming out. You see how. So I'm trying to reduce the heat inside this radio. So I'm going to remove this. I'm going to put back this sand resistor back in. And because it's still working, I'd like to keep it original if it's possible. And then I'm gonna, because I cannot put this diode here, I cannot put it here, there's no space. I'm gonna, as you see, I start pulling this electrical wire. I'm gonna install it here, away from this, away from this sand resistor. Here, as you see, there's some type of connection. I'm going to remove that, install this, and then we'll show you, you know, run the electricity to here. The diode, from diode comes here to the capacitor, to this resistor. So let me do that. Let me unsolder this again. You know, unsolder. Steve, you give me a lot of work to do. But I'm glad, I was thinking as earlier I shared with you in the other video that, somehow I have to reduce the electricity and, it comes in this my plan was, which I did a lot of tests. I actually could take this out, which I did, and put the diode right here, and the darn thing works unbelievable. But after reading this article, they were talking about this diode sometime when it failed. When it failed, they're gonna short it. It means, you never know it fell. More electricity goes through it. So I changed my mind. I'm not gonna just put here instead of that. And so I want to have the diode. From the diode goes to the stand resistor. I know I'm going to drop a lot of electricity, but these old radios, as I shared earlier, it works, in a very low voltage, and I will show you that. So that is my plan. Let me work on this. Start on soldering this, put these things on, put all the diode on it, run the wires. I'm very careful not to put my finger in this speaker. So let's unsolder everything. One more time, huh? How many times we're working this thing? Okay, folks, I looked through this schematic when I was doing all the testing, and I could not find this sand resistor anywhere in this schematic. Maybe I'm missing it. It's not even in the list. And then it's this resistor, which is when I take it out, I measured that it's about 70 ohm, and it goes between these two pins on 35Z5. And I add that manually, as you see. I add that for the calculation, what size I need. I watch Don at the restore old radios. He repair Air One 4028, and he has all the calculation there. He suggests to use 75 ohm, and please check over there for all the calculation. And so what I did, I took mine out, and so I want to work to see which what options I have. And sometime in the schematic, you will see those that some things are not there, unless it's here and I don't see it. So again, it's not on the chart. So manually, I add that to my own schematic. That's when I was doing all the testing. See, it's right there. I put it there. So the sand resistor, I cut it out, removed it, and we're going to test it so you see how much ohm it has. You see this one, and the original, the radio was about 71.2 ohm. So I'm going to increase this. All right. So that I removed it. Now, how are we going to test all this craziness? What I'm going to do, I'm going to use my multimeter, the positive, right where the switch is. Right here, the switch, because I know the positive goes right here, so I'm going to put it right here. Okay. So I have two test wire. I'm going to use the green one where the negative from, the wire goes to this tube. I'm going to hook it up right there. Because remember, I removed the sand. I'm going to leave this here. Again, nothing in the power yet, right? And this side, I'm going to hook up to the other side, the pan where the sand resistor was right here. So they both connected right here. All right. This is where actually I'm going to hook up the resistors like this. The negative side comes right here, like that. And I can put my multimeter right here because I want to know the power when it comes through this resistor, the reduction of the voltage. I hope that makes sense, you know. So that's all we do, right? To test it. After all this hooked up, we're gonna plug this to the power source, and what I'm gonna do, I'm gonna hook it up to the other unit that I have. So you see the voltage and the amp and everything when we are changing the resistors. I also found a 5 watts, that's the 10 watts, 75 ohm. This is the only one I have, it is 100 ohm and 5 watts. That was 10. I'm going to also test this. Then, in my other radios, I use a diode. We're going to use that one too in a state of the resistors. The problem with those resistors are, and I can show you in other tests that I did, it gets so hot after even a minute or so when the radio is on. When you touch it, it's actually burning your hand. Both of them do the same thing. So let's go through stage by stage and look to see, what the result is using these different ways really to try come with type of solution. My goal is really, all these old radios, they run in low voltage. I'm talking about sometimes 60, 65 volts. They're going to start working, and they work well, believe it or not. My thinking is, these are 60, 70, sometimes 80 years old equipment. And I want to keep these equipments around for a long time. So to me, I might be wrong. To me is, if they're going to run with lower voltage, let's do that because we're going to save the tubes, we're going to save the resistors, save the capacitor. I promise you, the reason that I had to replace almost all the resistor in this and capacitors goes bad, of course. There's resistors that were all bad because they hooked it up to 121 volts, and this is not designed for that type of voltage, so it masked all the resistors. Again, this is my thinking. I don't have electronic background, I use the logic. So if the radio work in those type of voltage, I'm going to do that. Why? Because is I want this radio to be around for future generation enjoy. And again, I'm thinking, why should I put 121 volt inside this little itty bitty radio? As a matter of fact, one asked you, so, how big this radio is? Okay, this is iPhone 8 Plus, and this is the radio. You see? My iPhone 8 Plus is bigger than this, so there is not that much space under this radio. So the options are, it's already packed, as you can tell. So the options is, use a smaller thing, and so it doesn't create a lot of heat, but still the radio work with no issue. Can we accomplish that? Let's try. We never know until we try, right? Let's do it.
Alright, that it is. We put that sand resistor back in the radio, and this is how much volts is coming. Is reducing the 121 volts to 100, almost 110 volts, 109 volts. And these are the amperage reading that
that's 119. So it seems like the sand resistor with 70 ohm, that what it showed, close 70 ohm, the radio operating 110 volts, and so anyway, we're gonna now test it with other resistors.
So if you increase, the resistor, of course, things gonna come together for you. But the issue I have with that, this is so large. I try to use this small one. This is a 100 ohm, 5 watts. I don't have 75 ohm. So it was getting too hot. Of course, this is a 10 watt, 75 ohm, but you see how large this is. This doesn't fit anywhere in this radio because it's so small. And it's very hot. This radio is on for just a little bit. You see, it's pretty hot. I mean, it actually burns your hand. Currently, I set this up. You see, currently is about 109 volts is is coming through here. If I move it to the other side, which is this is a negative side, if I add it here, you see it's 120 volts is coming to this radio. That's the negative side again. Positive is the switch. I always put positive in the switch. So this resistor is reducing the electricity to 109, which radio need about 110. The schematic says that it can run. So yeah, this is great, but this is too large to fit in that. Again, I tried a small one. They both get very hot, and this is a small radio. So what I did, I tried this in my other radios, and they work pretty well. I don't know if this is the best way to do it, but this again, it's I'm trying to figure things out. Like a majority of you, I don't have electronic background, but I had a two option here. These are diodes, one N5408 that each handle to 1000 volts. And this is it. This is a 3 amp. I'm going to replace that with one of this for you see the voltage going to drop, but it still sounds unbelievable, the radio. So my thinking is, if the radio works with lower voltage, why should I put a lot of voltage in this old, I don't know, it's about 60, 70 years old radio. If I want to keep it around, let's put enough voltage for radio work so it lasts longer. The tube's not going to put too much stress on them. Again, this is my thinking, so we're going to do that. You say the watt, is a 26.6. Actually, the amp is 0.024, and it shows about 119, almost 119 volts is coming to the radio. Of course, this is much better equipment, so this is read much, much better. Actually, as you saw, the current, actually the voltage come through is 121. So I'm going to use this one as a reading because it's much better unit than the other one. So anyway, I'm going to turn off the radio from the power. Okay, as you saw, it turned off. I'm going to replace. Man, this is hot. It is very hot. And so I'm going to put it here. Don't want to burn myself. I tried this, and they both work good, but it's so darn hot. We're going to use this. So I'm going to put this bar where negative. Negative is coming through, the negative side, and this is the other side. This is going to replace the resistor. So I'm going to turn on the unit. You see, it's working just perfect. The reason you hear the static is that, because there is a couple of fluorescent lights on. So it's working. Now let's check the voltage, okay? I'm going to check this side. This is directly from the negative side. And you see 121, exactly like the other one is coming through. This side, I'm going to put it right here. Watch here. There is just 65 volts. You know, it comes through the radio. No, does the radio work? Watch here. You see, it worked. So I don't know this is the best way of doing this again, but I prefer using diode. As you see diode this way. It's because diode does not get hot. It get hot, but not like these resistors. You know, and if again my thinking is, if the radio work, you know, with lower voltage, why should I force it with higher voltage? You know, that it can damage capacitors, resistors, especially tubes that is getting so hard to find. Does this make sense? I don't know. It's working. You know, I'm sure some people will say, "Oh, you shouldn't use diode over there. You should use resistors." I totally understand. This does not fit in for 10 watts, and this one is, you know, even if I find 75 ohm where it's, you know, 5 watt, it still gets so hot after a few seconds. The original, you know, was working very well. The radio, as you noticed it before, worked very well. Again, I don't know about the calculation of electricity, anything like that. I just know this thing working. I mean, it's working. I'm running this for a long time with diode, and radio is working. No issue. I use this system with this type of diode, 1 amp, because right now this radio, it comes about 0.16 amp comes here. So this is 1 amp. So this will handle it, but I'm going to use a 3 watt, you know, to make sure it's protected, you know, if something happened. Anyway, that's my thinking. Is this the best way to do? I don't know, but you know, the experience shows that it's working. It's working. You see, it's working. You see? I haven't even turned it on all the way. The only difference between diode and the resistor, the sound is just a little lower. That's the only thing I noticed. I don't mind to crank, you know, the volume control, you know, give it a little, crank it for radio work, you know, that way, if I can protect, the thing is almost 70, 80 years old. I don't know when this was built. I think it was built in the 1940s or 30s, sometime late 30s. You know, so hey, you know, it works.
And this is another test. What I did, I put a diode, comes from negative side, and then after the diode, I hooked it up to the old sand resistor to see if it works or not. And of course I turned the volume down, and still the radio work. Of course the sound is a little lower, and look at the voltage that we are receiving, right? And the radio still is working. And I touched the resistor, it is still hot, but of course as not as hot. Even if I had this resistor, if I didn't remove it, just add the diode, this radio could work. Let's check the sound. Still working very well. You hear that? All right. Just want to, this is the test I'm doing for myself, you know, and it's working.
Anyway, I hope this helped you to rescue more radio. You take care.
I want to take the opportunity and thank you for taking your valuable time watching these videos. If you're interested to see more videos like this, feel free to subscribe to my channel and you will be notified when a new video being uploaded. You have a great day.